I'm going to walk through step by step on how to get a basic servo motion going on a best robot using the VEX V5. So using the V5 three-wire servo on the VEX website is not specific to best robotics. You'll notice that this servo looks different than the hobby servos that we use in best robotics. This also has a male connector on the servo, and the servo I have does not. It has a female connector. I'm going to use header pins to make that junction between the two. So I'll take my servo extension wire or three-wire extension cable and use a header pin to connect to the servo itself, and then I'll plug the extension wire into the brain. I'm using about a 15 millimeter long header pin. Each side is 7.5 millimeters, and the pitch between these is 2.54 millimeters. It should come in your consumables kit, and it might already be super glued to the end of the servo so that you don't lose them. I'm going to be pushing the example from codev5.vex.com to my robot brain and then running a servo. So file, open examples on codev5.vex.com. You can click on the categories up here under motion, and it will limit what you can see. I'm going to go to servo movements. And then although this is set up to be able to use a VEX servo, it will work for the hobby servos on best robots. If I go to the hardware device manager over here, you can see they have two smart motors and they're configured with a drivetrain. I'm going to delete those. I don't need them for my best robot. So we don't use smart motors on a best robot. And the drivetrain's not all that helpful either because they're not smart motors. So just using a servo. And then I guess technically this part down here no longer applies to my example. The claw motor and the arm motor I just wiped out of the devices over here. And I'm not using a V5 claw bot. So I'm just working with a servo motor and a three-wire port. And then I'm just going to call this best servo movements. I'm going to save my file up here. I just opened one of the default examples, and it's just got this name, VEXcode project. I'm going to call this best servo A, full range, and save it to my computer. And then on my devices, I have the battery cable connected, and my micro USB cable already connected to my computer. And then I have a servo with the servo extension wire. Notice it's keyed on one side. Plug it in to the keyed slot on the side, servo port A, and it should go all the way in flush, the white wire up. And then I already have the header pin here. Again, your header pin may be super glued to your servo, or if you happen to have a servo that already has the male connectors, you won't even need this header pin. But my header pin is needed because my servo has a female connector on it. And then when I wire these up, notice the servo is not keyed, but I can just line the colored wires up. It's not recommended to plug this directly into the brain because your header pins will get stuck in the brain. But if they are super glued to it, there's a chance that you could use it and plug it into that directly into the brain, but it's not keyed. So make sure that you get the white wire, the signal wire is up, facing the front face of the brain when plugged in. Otherwise, you won't get movement. So black wire to black wire, white wire to white wire. And then I've got a little red piece of tape here so I can see when my servo moves. When it's not under power, I can move this servo about 270 degrees, almost 230 degrees. However, whenever I program it, I'm going to be restricted to just 100-degree motion. So I'm going to go ahead and spin it all the way counterclockwise as far as it'll go, just so I have a reference point. And then I'm going to download this best servo to slot 1. You can choose which slot you want to save your program to on your brain, up to 8 slots. If there's already a program on it, then it will wipe it out. So if you already have other programs on your robot, you may want to choose one that's open. I have no programs in my robot right now, so I'm just going to go with slot 1, connect to the brain, click the little drop down button up here to the right, connect. Just accept everything. Choose one of the COM ports that says VEX Robotics. The brain icon should turn green up in the top right, letting you know it's connected. And then I can be able to click download. And then hopefully because I named my project and I know which slot I saved it on, I'll be able to find it later on my robot to be able to run it. But for now, because I just pushed it, I could just press the start button and be able to see on the robot what happens. So play, that's the initializing. So it just went to 0 degrees, and then it's going in 25-degree increments, 5 steps up to 100 degrees. So you can see that's pretty accurate on the 100 degrees. Press stop and play again. There's the 0 degrees. So it starts basically facing south here, and using that as a reference point, and ends at 100 degrees in the counterclockwise rotation. So 0 degrees reference is here, 100 degrees is counterclockwise, 100 degrees from there. And then on my robot, I could press the red power button to click out and get out of that program, press stop, and then I could press play to run it again. And you could kill it at any time. Notice I didn't ever even connect a controller to this. There's no joystick controller plugged into this. I'm just using the brain, the servo extension wire, a header pin to make a jump junction between those two wires that were both female, and a servo, a battery cable, battery, and a micro USB cable to be able to push code. And then you can use pretty much any device that has a Chrome browser on it to be able to open up code v5.vex.com and then go to File, open examples, and then go to Motion and open up this servo example, servo motion example. To turn off your brain, just click and hold the power button for 3 seconds, and then you're ready to go on to the next challenge.